Today we're going to be discussing gas detection products. This is Barry with ACI, and this is Stan from QVL, and they're going to be doing the training.
First of all, thanks for everybody showing up tonight. I know it's difficult to come here sometimes, and you guys are all busy, but I'm Barry, like Mike mentioned. I work right at the factory at ACI up in Middleton, Wisconsin. We're a manufacturer of sensors, temperature, relative humidity, pressure, and current sensors and switches. We also manufacture interface devices now too. And I'm just here going to show some of the newer products that we're introducing down at the ASHRAE show at the end of this month. So you guys have a little bit of a sneak peek, and then I'll turn it over to Stan, who's going to be covering more of the gas detection sensors and controllers and how to set everything up with those systems. So first thing I'm going to show is our power meter. And with the, I was mentioning in the other class, that energy costs going up, a lot of people want a second source to really see, what the amperages are, or the power is, the usage of their buildings. So what these will do is just clamp on the current sensors, or CTs I should say. These are a small split core style design, and what we offer too is the rope version, which will clamp off and around and go up for the higher amperage ratings. So that's nice to have these for building owners, so they can see what maybe the power hogs are, what device or what that you guys may need to service for them to help them save power. So that is our Power Scout, what we call kilowatt hour meters. We're manufacturing a wet-to-wet differential pressure transmitter now too. It's called our WPR series. This is the Dash 100, so this one simply goes up to 100 PSI. And it's jumper selectable pressure ranges. Yeah.
Do you have anything the lower range?
This will jumper select all the way down to, I believe, 10 PSI.
Smaller, lower static pressure?
Yes.
For air, right?
Yep, that'll be covering that next. This is our more of a wet differential pressure, so on pumps. Our competitors have the sensors installed right inside this enclosure, and what you have to do there is run plumbing to it. A lot of times to turn it on, you have a 3-valve or a 5-valve manifold, which costs a lot more money to install. Our sensors are right on the cable to the Packard fitting, so you can actually take the sensor right off and plug it into the high and low side of the pump. So instead of hiring a plumber, you can actually install it yourself. And they're both labeled high. One's labeled high, I should say, one is labeled low, so you know what sensor to put it on. And again, high and low on the cover. We also have a Dash 300 PSI, so the WPR 300, and that's jumper selectable up to 300 PSI. And it's analog inputs, analog outputs are all jumper selectable, 0 to 10, 0 to 5, and 4 to 20 milliamp. So that'd be wet-to-wet differential pressure. So as you mentioned, we have inches of water column, so dry side, and we can go down to 0.1 inches water column, all the way up to, I believe, 20 inches of water column. So this is our new mini low pressure, or MLP. It's a lot more smaller footprint, smaller design enclosure. It also has the auto zero function and the span function on the right of the side of the push button. This is just a standard temperature sensor, immersion well temperature sensor. What I wanted to show you guys today was the new design that we have. There's no more. We do have the metal enclosure still that has the screws on the front, but this is the screwless cover head that simply snaps in. So it's a nice, easy thing for you guys installing in the ductwork or anywhere else emerging for these. This is our new wall enclosure for all of our temperature and humidity sensors. I don't know if you guys have seen this yet or not, but we have shown here today as our new CO2 sensor in this type of enclosure. We're also offering a temperature combination CO2 temp with set point adjusted and override. So I went through the new products pretty fast, but if you guys have any questions, feel free to ask. Otherwise, I'm going to switch it over to Stan with QEL, and he's going to cover the gas detection sensors.
Okay, my name is Stan from QEL. I'm from Ottawa, Canada. We are the manufacturer of QEL gas detectors. We started the company in 1986, and we started from building temperature controllers, and we moved right into gas detectors from that time. We sell not only in Canada, but US and the Far East and in Europe. We cover commercial as well as industrial applications. We've been working with ACI since, I was going to call CSI, no, ACI since about 1990. So it's been a long association. This is our factory. We have 18,000 square feet. We built the building. We are a private company, and everything that we sell, we design ourselves. So we focus on the protection of life, property, and the environment. A lot of the products that you see now are results of what our customers have wanted, whether it comes down to the actual size of the unit or software, or even down to the size of the terminal blocks and how easy it is to install. So we always welcome the feedback from our clients. What do they like to see in the next generation of product? So generally we're divided into three: hazardous and combustible gas detection, which is what we're going to concentrate on today, optical flame detection, and combustion analyzers. The markets served is the markets you guys are in: commercial HVAC, whether it's parking garages, condo underground garages, indoor air quality, shopping centers, institutionals, colleges, hospitals, museums. Industrial, we're into pulp and paper, petroleum, automotive, pharmaceutical, and gas separation. We're on bottom of offshore oil platforms for our industrial line. Municipal, again, we're looking at libraries, arenas, indoor swimming pools for chlorine, landfills, whatever municipalities, whatever buildings they own, we are able to supply the gas detectors for that. Military applications such as aircraft hangars, tank overhaul facilities, mess halls, buildings. We presently we have about 80% of the market for Canadian Forces bases across Canada.
Canada has an Air Force?
Yeah, believe it or not. We sent 3 CF-18s to Syria. We have an Air Force. It's big news in Canada. We went on 4 bombing missions. Yeah, yours is like the real cars. Real planes, ours are like the little dinky cars. I know. But when it comes to aerospace, we were invited back in 1997 to supply a gas detector for the monitoring of hydrazine for each launch of the shuttle. 12 companies were invited. Only one company met and exceeded the spec, and that was ours. So we were sole source for that application for one of our products. And we just recalibrated 50 gas detectors the past couple of months for the latest SpaceX launch at Cape Canaveral. So hazardous gas detection, I'll quickly go through how the sensors work. An electrochemical sensor is like your car battery. You have a couple of electrodes in there. You have current across the electrodes that gives you the proportion of the gas. So when you do a CO sensor, for example, you choose an electrolyte. An electrolyte is the conductive fluid. The electrolyte reacts with the gas that you're looking at, and you get a current. And that change is proportional to the gas. If you have very high concentrations for long periods, you wear out the cell because you use all the electrolyte, like your battery. Catalytic bead sensor, similar. In this one we have a reference bead and an active bead, and basically the active bead is covered with platinum, like like you find in catalytic converters in vehicles. When it comes, it's heated, and when it comes in contact with combustible gas, it burns and it changes the resistance of the unit. It's compared to the reference bead, which has no coating on it, and that change is proportional to your gas concentration. They respond very, very quickly, but if you have a lot of gas, they require frequent calibration. The third type we have are infrared sensors, and this is a non-consumable sensors because you can have a very high concentration of gas and you're not going to wear out the sensor because there's no chemical interaction with the sensor element. And basically the way it works is that you have a light source at one end of an optical bench, and inside the bench, which is just a pathway, you have a very, very highly polished reflective surface. You choose the light source such that you have the wavelength is the same as the gas you're looking at. So if there's no gas present, 100% of the light is transmitted and it's collected by the other end of the source. If there is gas present that has the same wavelength as your light source, it's absorbed and you don't get 100% transmittance. So you actually see a decrease in the signal, and that is proportional to your gas concentration. Advantage of these sensors in industrial applications where you have a lot of methane or combustible gases, like in petroleum refineries, you always walk around, there's a smell of some gas. With catalytic sensors, you're replacing those maybe every 4 or 5 months. These will last 10 years. Our most recent application was for Diageo, and they're the largest distilling company, one of the largest in the world. They do Crown Royal and all these high-end whiskeys. And we did a facility in Montreal where they used 30 of these sensors. It was over 15 warehouses. So you walk in there, you can get drunk if you stay there for more than 15 minutes. But they were using catalytic sensors in the past and having to change them every 4 or 5 months because the sensors would wear out.
If you need a job site visit there, Jackson Systems will help out.
Okay, no problem.
Check it out.
So they installed electrochemical sensors. The payback was within a year. And you pay more for it, but you don't have the maintenance, and you check the calibration once a year. So you don't need all the extra personnel to do that. We also use infrared sensors for our refrigerant monitors, which I'll go into later. So transmitters, so I went over how sensors basically they work. Transmitters, we have 4 to 20 units, industrial and commercial, with non-intrusive calibration. Also digital communication. I'll just quickly go over the basic ones. This is the QTS 6000. If you want a simple toxic sensor with just a 2-wire device going to a monitor, you can use one of these, and these are for all the toxic gases. This is our low-cost CO sensor, which ACI sells, and we private label for them. This comes standard with a display, also an adjustable 4 to 20, RS-45 or daisy chain communication. The only options are really relays and buzzers. So if you want to use it as a standalone and also have an audible alarm, you can have it. Very rugged unit. It's been around a long time. I think ACI has probably sold in the past 5 years probably about 20,000 of these things. They sell.
Question. What's the range, adjustable range?
Oh, the adjustable range, it's 0 to 250. But what you can do is you can adjust the 4 to 20 milliamps to whatever you want in that span. So let's say you wanted your 4 milliamps to read 20 ppm and your 20 milliamps to read 100 ppm, you could do that. Or let's say you wanted just 0 to 50, you can make your 20 milliamps 50 ppm. The display will still be the same, but your 4 to 20 changes. So whatever you need, whatever range you need. It is linear over the whole range, so we're able to do that. This again is the industrial 4 to 20 unit. Again, wastewater treatment plants, wherever you have classified areas where you have chances of explosions. The M17 we don't build anymore. It's replaced by the Q series, which I'll get into. This is the new commercial Q series, and we have ACI has been kind enough to build a nice display case over there. It's a unit on the top right-hand corner, and that is our commercial light industrial type gas detector. It comes in a NEMA 4 enclosure. The enclosure itself, the base of it has knockouts, 2 on each side, 2 on the top and 2 on the back. So if you have to bring your conduit in and out, you don't. It's pretty easy for you to configure. The front cover also has a gasket on it, so a rubber gasket. So once you screw it in, it is rated NEMA 4. The sensor housing also is sealed. It screws to the front cover, and there's a rubber gasket there too. So if there's a guy, hosing a car or something, he's not going to ruin the electronics by wetting the sensor. It may just ruin the sensor. What comes standard with the unit are 3 relays, and you can adjust the relays to whatever levels you want. So if you want relay 1 for a low and relay 2 for a high and a relay 3 for a fail, you can use that. You can set the delays on and delays off for each of the relays, so that makes it very flexible. It also comes standard with RS-485 communication, or network communication, which you may be familiar with. It also comes standard with Modbus. We also sell the sensor cartridges, which is basically a replacement sensor with the board. So if you don't want to recalibrate it, you can buy the sensor itself and plug it in and recalibrate it. Or you can just pay $25 to $40 more and have the sensor already pre-calibrated, and you just go in and you plug it in. So it depends how many sensors you have and what's most economical for you. The display also shows your type of gas, your gas concentration, and your sensor number. So you may have 80 sensors in a system, and it'll tell you, okay, sensor 80 is offline. Well, rather than, if you know where it is or you want to look around, you can check it, and it shows you the sensor number. It also shows you, it displays your short-term exposure limit, your time-weighted average, and your peak daily value. And that's more, we designed that more for the OSHA people in university research centers, where they wanted to have a record of what short-term exposure limits and TWAs were of these really weird gases they were monitoring. So it's kind of a safety insurance thing for some of those applications. For commercial applications, it really doesn't matter. But what we do is we put it in there. Rather, we try to bulk everything into one unit, so it makes it easy to order. You don't have to order a control unit and a sensor separately. It's just one part number, you put it in. If you want relays, you don't have to order it. If you want it Modbus, it's already in there. If you want it RS-485 with our controller, it's there. So it makes it easy for the user to configure. We have another version of it, which is a BACnet version, and is a full BACnet MSTP. When we designed it, the prototypes we sent to Reliable Controls and to Delta and to Johnson's and Siemens. They tested it out and told us what we had to change, and we did it. And what the result is a fully compliant BACnet gas detector that will work on any system. And it's one of the truly ones that are fully BACnet. The relays on it can also be controlled by a BACnet controller independent of gas concentration. So if they have other parameters that they want to check and activate relays or something locally, they can use the relays on the BACnet sensor. So it makes it very, very convenient. With a BACnet sensor, you don't have the 4 to 20, but you have all the relays. So if you want a BACnet sensor, it's because you're going to connect it to a BACnet controller. So They all have buzzers on them, so you can activate buzzers if you use them as standalone, or even in your network system, you can have a local buzzer. So if you have a problem with the sensor, you could program it that the buzzer goes off to make sure that you can, hear it out and find out which sensor it is. So buzzers are also standard on that. We have a pretty long list of detectable gases. If it's not on our spec sheet, call us and we can usually put it in, or we know what it is. The M20 series is really our own CO2 sensor. Not really for a wall mount. You can use it, but ACI, I'm going to admit, does a much better job than what we do. But if you want a duct mount version with a relay, this is the way you go. You can use that. And as I forgot to mention before, the B series and Q series, you can actually have in duct mount versions. So if you're doing, NO2 or CO duct mounting, venting from, bus garage or something, basically what we do with a duct mount, is that we place an adapter over the front cover of the unit. It screws on. You see the triangle of the 3 screws, and we have a couple of fittings with the pitot tube that goes into your duct. Another unit that we designed that we're quite proud of is our refrigerant monitor. It's the only one that can be used in sub-freezing temperatures. We've been sole source by Sporlan, a division of Parker, for large refrigerated warehouses, so storage of frozen food, frozen meat, frozen fish. The old types, the way people used to do it before is they would have one monitor, and then they would use a sample draw system through using solenoid valves to monitor points maybe 600 or 700 feet away. The problem with that is if you had 8 or 9 points, it could take you an hour before you read point number 1 again. It just took a long time. But by having this in situ, you don't have any problems with that. And the other problems in the freezer applications, because they're typically very humid, as soon as it would come inside the room, you could have humidity problems in the solenoid valves. So what they were using molecular sieve dryers, and then that kind of affected the reading in some applications. So by this now, you have it in situ, you just run your cable to it, and you have real-time monitoring of all the sensors. The other thing is that we heat our sensor for 2 reasons. One is to prevent any humidity condensing or any condensation inside the optical bench. And 2 is that the IR sources are thermally dependent. So if you have cold temperatures, your light isn't going to shine as much, and you're going to see an increase in reading. Our competitors use plastic benches, which they can make as shiny as a metal one. The problem is you can't heat them. You can't prevent condensation, and you can't really heat plastic to a constant temperature. Only to that localized spot. So there we actually have an advantage. The units come standard with a display, also 3 relays, RS-45. The biggest feature of this is that you can select the gas type. So let's say Jackson Controls here has 2 or 3 in stock, and you go to their counter and say, you know what, I need a refrigerant monitor for R507 and I need one for R22. All they have to do is take it out of stock, give it to you, or they can power it up for you and select the gas that you want to monitor. So you switch it to R22 or R507 or R134, and you're off and going. You don't even have to recalibrate it. The advantage in a refrigeration application, if you're doing chiller maintenance and you're recalibrating sensors, is that you could have customers with a whole gambit of gases. All you need is one test gas. And basically, you go to that area, to that office or that plant, and you switch the gas on that sensor to the gas type that you have, calibrate it, then switch it back, and then go to the next spot. So it really cuts down on the amount of gases that you need and makes it very flexible. Or you have a client that orders it, they say, yeah, I need an R22, and you know, you order R22, and then it's a unit that comes with R134 refrigerant. Well, with other devices, you've got to send it back to factory and have it recalibrated, or order another one. You can do it right on site. Just change the gas type. So it's a big, big advantage. And that's what it looks like. This is the QTS 8000 series. This was the one that we designed for NASA, but we will use it in industrial applications. It comes with relays, Modbus, RS-485 communication, and 4-to-20s. And the reason we say non-intrusive calibration is that you don't have to open it up to calibrate it. In classified areas where you have, let's say you're in a plant where there's a lot of these nasty gases around, if you open it up and you accidentally cause a spark, you can cause an explosion. But with a non-intrusive device like this, we actually give you like a magnetic pen, and you go through the menu through the gas. So you go, you're up, down, accept, move ahead. So you never have to open it up. So you don't have to go on downtime. And you can actually, you know, take the unit offline so that you calibrate, so to make sure that, you know, it's doing its full span. You're not turning a whole bunch of alarms on. So you go into calibrate mode to, you know, shut down all the outputs. Now controllers, this is a Q4C. It's just a small controller for our digital sensors, either the M series or the Q series or the QTS series. So if you have a small condominium or a small warehouse and they only require 4 sensors, you know, something, you know, 30 or 25,000 square feet or less, you can use a controller like this, place it beside your fan starts, your motor starts, and just run a cable out to the sensors. So you can either have it in daisy chain, or you can run it out, you know, from the same terminal block to the 4 sensors separately. It doesn't matter. So it comes with four relays. It also has a 4-to-20 retransmission. It's a very low-cost unit, but you do have a controller. Again, it comes with displays. This is our M controller. This has been our bread and butter controller. It comes with 32 daisy chain sensors and 8 analog inputs. On board, 3 relays, as well as separate relays for a horn and strobe. So not using those 3, it has 2 other little mini relays. You can have remote relay panels that work on the same network as the sensors, as well as other accessories, which I'll get into. First one is an M switch, and basically if you wanted to turn on the fan or a relay, you address this switch to the relays that you want to turn on. So let's say you were painting the floor of a parking garage or something, you could just press the switch on and turn on the fans so you can ventilate the area. For another application, one of them are B52 mechanical rooms, ASHRAE spec B52. It states that you should have a manual override switch inside the mechanical room, and then at each entrance to the mechanical room. So before entering, you can press the switch and turn on. There's always constant ventilation, but this will turn it on to high rate ventilation. What's nice with this is this works on the same network, the same cabling as the sensors. So you can have an M controller, you know, a Q5 sensor, infrared sensor, and then you can have an M switch, and then you can have an M relay, all in the same network. So it makes it really slick to install. The M relay panel, as you see there, there's the M controller, and it's just a black box with relays in it, and that works on the network. The M logger and MNet basically are just optional items. The M logger is just a data logger, and that just records all the concentrations and all the relay activations. Comes with a removable flash drive. We give you the software, so if you want to look up date January 30th or December 25th, what happened, it'll tell you all the concentrations, and you choose the window you want to look at. Or there's software in there to tell you, okay, when were there alarms? And it'll go right to where the alarms were. The MNet gives the M controller an IP address, so it allows you to do remote monitoring from your office. It also allows you to do data logging and programming. So if you want to reprogram a controller from your office, you can dial up the address and go right into the program. We also have annunciator panels and remote readout. So you may have a remote panel in a main room, but let's say in a security office they want to see what the concentrations are. You can have up to 9 remote readouts. You just place it in there, and again that works on the RS-485 network. So very, very flexible. The annunciator panel also comes with a local buzzer, a display, and relay. So if you want to turn on a local strobe or something, you can do that also. The readout device is just a readout device. Doesn't do anything else. Whatever you need. Basically, if you need us to change the software, to make some modifications, ask us, and we'll tell you within a week whether we can do it or not. It looks like a Q4C, but it's just a different software in it. We also have sample pumps. You may find out, and if you're dealing with natural gas or ammonia, it may be really inconvenient to place a sensor 50 feet up a tower or something. So climbing up a ladder for that is inconvenient. And consequently, you may have a trench where propane may accumulate. So if you place a sensor in there, you have a chance of flooding and you'll ruin the sensor. So by having a pump, you place that on the wall and you run a tube up to where your sampling point is. It'll draw the sample in, and then we can push it into the sensor. One of the reason we did trenches is that about now 9 years, we did 50 arenas for the city of Ottawa. And so we did the seal monitoring, the ammonia monitoring, the propane monitoring. But what they found out in the propane monitoring, you always have a trench in the Zamboni room where they dump the ice or the old snow. Well, if you have a propane leak, because it's heavy gas, it'll automatically go into the trench. But what happens if you have snow in there? Well, the gas isn't going to go in there, and you're going to ruin the sensor. So what we did is that we developed this pump with tubing that goes into the trench. But if there's water, and we don't stick it right on the bottom, we put it about halfway down. If there's water, there's a liquid detector on the pump. So automatically it pumps, it shuts off, it tells you we're not monitoring right now, there's something wrong. And it saves you from having to buy a new gas detector and a new pump. So you're starting to pump dirty, murky liquid in the pump, and in a gas detector, you're none too happy. So that's one of the little things that we do. We have a little water detector in there. This is just when you're looking at placing sensors, what's important is, okay, 2 questions you should ask, 2 or 3. What gas do you want, which they normally tell you. But there's 2 considerations. Your radius of coverage, how much will a sensor cover, and where should I place the sensor? So if it's heavier gases, you normally place it close to the floor, about 12 inches off the floor. And of course, light gases like ammonia and natural gas, you want to place close to the ceiling. So this is just basically a chart that gives you a general overview. There's always a question with NO2. Because NO2 is heavier than air. Traditional thinking thinks, okay, well, we should place it close to the floor. But when you have a fire engine or a dump truck going into a service bay or parking, you have the exhaust stacks pointing to the ceiling. So you can also place the sensor close to the ceiling. Because the gas is warmer, it will detect it quicker than before it sinks down to the ground. And usually roofs of buildings, and those types of buildings are usually warmer than the ground. So it may take a few minutes before that gas reaches the floor. And at that time, you can have a lot of smoke in your garage. So not that it's NO2, but you have all the unburned diesel components that are up there, and people get upset. So ideally, from a sales point of view, it would be nice to have the NO2 on the top and an NO2 on the bottom. And if you do have diesel vehicles or diesel pickup trucks with exhaust to the floor, you should have a sensor close to the floor. So that's just an exception to the rule, which I know you guys, we often get asked questions about that.
So what do you really do for a parking garage where they're concerned about diesel cars and trucks?
Place them close to the floor, if it's just for cars and trucks. Because normally you have a height limitation. Most of the exhaust stacks going to the ceiling are for big trucks, you know. The majority have exhaust close to the floor, so we place it 12 to 18 inches off the floor, at the height of where your exhaust would be. So because the exhaust gas, of course, is warm, it's not going to rise that much, but it's eventually going to stay closer to the bottom. And that's where you'll pick the NO2. The exception to the rule is buses and those dump trucks where they have exhaust to the top. Flame detectors, these are, this is really for military applications. These things are pretty neat in that it'll detect the flame 200 feet away for the top of the line one, usually connected to your fire alarm system. These are used in aircraft hangars, in jet fuel storage facilities and things like that. If there's any spontaneous ignition from combustible fuels, this will pick it up. You can even have CCTV cameras to look at the fire and things like that. And that's it for that particular part.
Question.
Yes.
What standards does this currently meet in the US? UL, ETL, what do you?
Yeah, we have the Q series is now ETL CSA, so it meets that. The controllers are CSA, well, equivalent CSA US, so they are certified for those standards. Yeah. We got the Q5 and the D5 certified this year to get that for the specifications.
Can you talk briefly about calibration as it comes out of the box and recalibration requirements?
Yeah.
For the products?
Yeah. The units come calibrated. If you require a calibration certificate, you request it, and ACI, we will provide it to ACI, and we will give you that. You don't have to calibrate it when it's installed, because usually they don't stay on the shelf that long. They're usually recently calibrated. What we recommend for calibration is usually once a year. Like you guys are doing mostly CO&O2. So normally at the beginning of heating season, like in the fall, you want to check it once a year. What's neat with the calibration is that you don't need any multimeters or anything like that. It's all menu driven. You get into the menu, it does a zero cal, it tells you open the gas, you open the gas, and it says wait, and then it says accepted, then it tells you span gas, it goes to the next step, connect your cylinder, open it, it waits for a minimum response. So it gets a minimum response and it looks for stability. So after about a minute, once it's taken about a minute to stabilize, it's accepted and it's done. So it's all electronic, you don't have to open it up, and usually the calibrations are good for about a year. Even more, 2 years. If there's a lot of gas, you should do it more frequently, simply because the sensors are like fuel cells. If the sensor is at its end of its life,
Which is how long?
usually the CO sensors now are minimum 5 years. Minimum 5 years. If you have a concentration where you've had 500 ppm for 2 weeks, you're drastically going to shorten the life of that. But the replacement cost of the sensors is very low. Some of our competitors, you know, if you buy a sensor, you may as well buy a new transmitter. In our case, it's very, very economical. And you can plug the sensor in, or you can buy a sensor with the board pre-calibrated and plug it in also. And I would recommend that for some of the weird gases. So if you're doing ammonia or something, it's cheaper to buy a sensor than to buy a whole cylinder of gas. Ammonia gas is extremely expensive. And the other thing is, it's a reactive gas. They only guarantee it for a year in the cylinder. So after a year, it's no good. So in some instances, or the other thing you can do, I mean, if you have a spare sensor, just send the other one back to us and we'll recalibrate it and send it back to you. So you can always have a spare. We do that with some of the municipalities in Canada for swimming pools. So we actually have an exchange program. So every 6 months, we send them out sensors, they replace them, send the old ones back, and then plug it in. So they have a couple of techs that go around to do that. So we have that recalibration program. Cost of the recall is $50. So it's relatively inexpensive. Yeah, so the sensor lifetimes are good, at least 5 years for CO sensors. The NO2 sensors 2 to 3 years. Replacement cost is very reasonable. Our after-sale service is excellent. If you need to talk to a technician to program a unit, or you have something wrong with the unit, call us. We will tell you what to look at on the board, or read the error codes, and we'll tell you, okay, you got to send it back to the factory, or no, reset it, or just move this over, and you can get it off and running. So it's our technical support, as you say. You guys do a very good job. Sometimes, it's something weird, and ACI says just call Simon or Glenn or somebody at the office, and they'll walk you right through. We sell these controllers all over the world, and we don't know the sequence of operations when they leave. And often we do it over the phone, and we have controllers beside our desks, and we tell them press this, press this, press this. And then once they get the hang of it, some guys it takes 4 or 5 times. Most guys 1 or 2 times, and then they can teach us. They know what to look for. So it is the software in it. Even if you're using the keypad, it is intuitive. So you can program the unit quite easily. If you get into see here if I can do this again. Oh, this happened last time. Okay, now I know what to do. This is the program that comes with each of the M controllers. And I don't know whether you guys get involved in programming or not, but I'll just show you how easy it is. Basically, you turn on the number of sensors that you have in your system. So if you had 5 sensors, you turn 5 on. You select the gases that you have. You select the units, whether it's ppms or whatever. If you have analog ins, so let's say you had a temperature probe, or maybe a flow probe or something, you can go in here and put flow, and you can put rename the type. You can put gallons per minute, rename the type. You can go in here and you can go to the drop down menu. Flow, gallons per minute, and then you can go from zero to whatever you want. Maybe it's 1,000, I don't know. So you can also, if you have existing 4-20s, you can tie them into your controller, and it will come out on the display as that. Relay style, it has 3 relays on board. You can choose normally energized, so basically your relay closed, you have current going through it. So if there's, you can have that in fail-safe mode, so if there's a controller or you're operating a device that needs to be shut down when there's power shut down or something, it'll open when the power's turned off. You can have latched, you can have voting. Basically voting is zoning. So if you use voting number 1, it means that if you have 100 sensors addressed to one relay, if one of the sensors reaches alarm level, your relay turns on. So that's voting number. Yeah, voting number 2, it means that 2 of the sensors that are addressed to that relay have to be in alarm before the relay turns on. Okay? Then here you can have your on delay. So this is where you are. You're in a parking garage. You're in your spot in your condominium, and you turned on your car, and then you forgot something in the trunk or something, and you open it up, and your exhaust is pointing to the right by the sensor. You may have a high alarm. You get back into your car, and then you leave, and then you see a good-looking woman, and then you talk, and then again your exhaust is there. You may have a very high alarm. You may not want to evacuate the whole garage because you have a very high, because you have a spike. You may want to wait a minute or two to see whether that gas, whether that concentration is up there. Because often you'll see a spike and then it'll go down. So you may want to put a 1-minute delay before you turn the fan on. So that becomes very expensive if you have the fan on every time it sees something. So you can have an on delay as well as your off delay. So you may have it set at 50 ppm, and at 10, once it reaches 10, it says, okay, shut off the relay, shut off the fan in 2 more minutes, and you shut it off. So it's that easy. Then here you assign sensors. These are all the sensors that I turned on. This is relay number 1, which I turned on. And now I can assign my sensors to the relays, and then I can assign my set points. .50 or whatever, 509 and 5, and I can do whatever I want. Relay number 2, I can maybe assign all the sensors. And I can set the limits individually for each sensor, for each relay. Now relay 2 here, did I put a, see, I didn't put his voting, so I couldn't assign it. Now I can assign it. If I didn't have averaging, if I had averaging, it just takes an average reading of the sensors, and you have to set that. But basically what this tells you is that you can assign all the sensors to all the relays and set individual limits for all of them. And what's neat with this is that you can save the program and you can print it out. So if somebody comes to ask you, how the heck do you have this programmed? You can show them, say, okay, sensor 1, 2, and 3, and 4 are addressed to relay 1, and it turns on at 20 ppm and off at 5. So you actually have a printout of all the parameters, and you can also store it on your hard drive or transfer it to a thumb drive on your laptop. So very, very flexible software with the unit. Again, all of our calibration is non-proprietary, so anybody can calibrate the unit, unless Jackson wants to put, different passwords in there, and they can only do it. But it is an open source, so you may end up having a company that does calibration. There may be some that do that in the area. You can subcontract to them. It's very easy to do. All the calibrations instructions are on the internet. You look up the manual and you go into calibration. You won't see consult factory. You'll actually see the calibration procedure. But it is all menu driven anyway, so it's pretty easy to get into.